Getting a perfect color match in the lab, that's one thing. But getting that exact same color to work in full-scale production, poof, that's where things can get really tricky. Today, we're going to pull back the curtain on the science that separates the pros from the amateurs, and we're focusing on two huge factors: pigment strength and opacity.
Oh, we've all been there, right? You feel this frustration. You nail that perfect shade, you're so proud of it, and then suddenly, when you scale up, it's over dark, or way too white, or just looks flat and dull. I'm here to tell you that's not bad luck. It's a science problem. And today, we are going to walk through the solution.
So here's our roadmap. First, we'll nail down the core problem. Then, we're going to build a solid foundation with pigment strength. After that, we'll dive into the secrets of white and black pigments. They're critical. Then we'll tackle opacity, and finally, we'll wrap it all up in a pro playbook to help you go from making mistakes to true mastery.
So what is the real disconnect between that perfect little lab sample and the giant batch on the production floor? Let's break down exactly why that beautiful lab match so often falls apart in the real world.
You know, it all boils down to a single root cause. This isn't some kind of mysterious magic. It's about a lack of control over two fundamental properties: the raw power of your colorants and their ability to hide what's underneath. If you can get a handle on these two variables, you can master consistency. It's that simple.
So let's jump right into the first piece of this puzzle: pigment strength. Trust me, this is the foundational concept that pros think about every single day to predict and control their results. In the simplest terms, think of pigment strength as efficiency. You know, how much color bang do you get for your buck? A high-strength pigment gives you a ton of color with just a tiny little bit. On the flip side, a low-strength one needs a much bigger dose to get the same job done. Ignoring this is where so many problems start.
Okay, now let's get a little more specific, because this is important. For most jobs, we're not using a pure raw color. We're mixing it with white, right? So the thing that really matters is a pigment's tinting strength. That's its power when you mix it down with white titanium dioxide, or TiO₂. This is the metric that is absolutely key to accurate matching.
And this slide just shows it perfectly. Look at this. On the left, 1% of pigment A in white gives us this light pink. But over on the right, the exact same amount of pigment B creates a much richer, darker shade. I mean, that's a crystal clear demonstration. Pigment B has a way higher tinting strength.
So you're probably asking, which one is better? Well, it's not that simple. Each one has its trade-offs. As you can see, yeah, high-strength pigments give you these amazing, bright shades with a tiny dosage, but they are really hard to control, and you can easily overshoot your target. Low-strength pigments, though, they give you amazing control for those smooth, subtle shades, but the final color might end up looking a little, well, dull.
And here it is, the pro tip that brings it all together. You don't have to choose one or the other. The real art is in balancing them. You use a high-strength pigment to get that pop and brightness you need, and then you use a low-strength one to fine-tune the shade with absolute precision. This way, you get the best of both worlds. You get vibrancy and control.
Okay, let's talk about the two most critical and honestly, the most misunderstood ingredients in any formula: white and black. Getting these right is about so much more than just lightness and darkness. Their hidden complexities can literally make or break your match. First up, titanium dioxide, TiO₂. And believe me, it does way more than just make things white. It is the absolute backbone of your formula. It controls not just the L value, which is the technical way of saying lightness, but also your opacity, your brightness, and that clean, crisp look you're going for. And listen, not all TiO₂ is created equal. The two main grades, rutile and anatase, have totally different personalities. Rutile is your workhorse. It's got high opacity, super durable, perfect for outdoor stuff. Anatase, on the other hand, is less opaque, but it gives you this incredible brightness, which makes it ideal for indoor products.
Now this is a critical insight. If your white match is failing, there's a 90% chance it's because of your TiO₂ quality. Good quality TiO₂ gives you a clean, brilliant white with strong hiding power, and you don't need to use a lot of it. Cheap TiO₂, on the other hand, looks grayish, it has terrible hiding power, and it forces you to use more and more, which just throws your entire formula out of whack.
Now for the other end of the spectrum, black pigment, specifically carbon black. And yeah, you read that right. It is often called the most dangerous pigment to work with. And why is that? Because its power is almost unbelievable.
0.01%. Just look at that number. That tiny, almost immeasurable little speck of carbon black is enough to cause a massive shift in your shade. If you overdose even slightly, you can completely kill the color. That's why this pigment demands absolute precision.
So here it is, the non-negotiable golden rule for using carbon black. Never, ever add it directly to your main batch. The risk of messing it up is just way too high. The professional method is to first create a dilution, or a master batch, where you mix the black with a carrier. This gives you the control you absolutely need to add it safely and precisely.
Okay, we've covered pigment strength and our key ingredients. Now, it's time for the final dimension of a perfect match, opacity. Because I'm telling you, if your opacity doesn't match the standard, your shade will be rejected. It doesn't matter how close the color is.
So what exactly is opacity? It's really simple. It's hiding power. How well does your color cover a surface and block out whatever is underneath it? A high opacity color will completely hide a black and white background, while a transparent one is going to let it show right through.
The good news here is you can totally control this. You've got 3 main levers you can pull. The most direct way is to just increase your TiO₂ content. The second is to lean towards inorganic pigments over organic ones, because they naturally have better hiding power. And finally, optimizing your pigment particle size is key. Getting that size just right scatters more light, which directly boosts your opacity.
Okay, we have covered the core theories. Let's bring it all home now. Let's put this all together into a practical playbook that will help you avoid all those common errors that lead to rejected batches.
So let's wrap this all up. The path to mastery really means avoiding these common traps, right? Don't just focus on the color. Manage your pigment strength. Don't try to fix a dark shade by just dumping in more white. Never add carbon black directly. Always use a dilution. And finally, don't skip the opacity test. Avoiding these is your direct path to consistent success.
So now you have the building blocks. You know how to control pigment strength, you know how to manage your TiO₂ and carbon black, and you know how to master opacity. But what happens when a shade is still just slightly off? Well, next time, we're going even deeper. We're going to unlock the formula for perfect shade correction using the LAB color space. We'll show you exactly how to read the data so you know what to add to nail your target every single time.
Day 4. What you learn: pigment strength control, tinting strength fundamental, TiO₂ quality difference, carbon black handling, opacity mystery. Coming tomorrow, day 5. We move to the core science of color matching. LAV color system, delta E reading and interpretation, shade correction formula. Once you understand day 5, you will be able to match color. Hit the like and subscribe. Thank you.